Okay, okay, Jai Shri Gurudev. I would like to begin this event by submitting my pronouns to His Holiness Bhairavikya Padma Bhushana Sri 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 Dr. Balagavanatha Swami Ji, and also submitting my pronouns at the lotus feet of Paramapuja Jagadguru Sri 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 Dr. Nirmalanandanatha Mahaswami. So today's event, this will be the timeline of activity. So from 11 AM to 11:05, welcome note by Dr. K.M. Ravikumar sir, Chief Patron, Principal, SJCIT. From 11:05 to 11:10, introduction of speaker, Dr. Anush K. Chandrapa, IIT today's speaker. And from 11:10 to 12:30, the session will be taken by the speaker. He will deliver the lecture. And from 12:30 to 12:45, the session will be open for question and answers. And 12:45 to 12:50, vote of thanks. And by 1 o'clock, we will wind up the program. So now I request our beloved principal, Dr. Ravikumar K.M., Principal, SJCIT, to present the welcome. This over to you, sir. So just check whether
sir,
mic is on or not.
Yeah, your is fine. I do everything. So, sir, Dr. K.M. Ravi Kumar, sir. Can you speak, sir? Sir, Dr. K.M. Ravi Kumar, sir. Can you hear me? Your voice is not audible for us.
One second, Som. I'm helping him.
Okay.
Wait for a few minutes.
Okay. No problem.
Som, can you able to hear me? Som?
Yes, sir, I can hear you.
Som, he log in with another number. You can check with DK.
Oh, okay.
DK. So you kindly provide the option for him.
1 second. DK, you are saying?
Yeah. Dr. K.M. Ravi Kumar.
Dr. Ravi Kumar K.M. is another name. Is it fine?
Yeah. One more. I will leave this.
Yes. So,
Okay. Yeah, so the issue is clear. You can speak.
okay.
Yes, sir. Move to the I request our principal, sir, to present the welcome note. To welcome the participants.
So, Jai Shri Gurudev. Jai Shri Gurudev.
Jai Shri Gurudev.
So, I welcome all the participants for this webinar. My pranams to all the Mahaswamijis of IIT Pavement and seeking their blessings. Respected resource person for today's program and HOD, faculty members from SJCIT as well as from all the other higher education institutions. First of all, I would like to welcome Dr. Anush N. Chandrapa, BHUBANESWAR. Sir, I welcome you for this particular program. And first of all, I would like to thank you for accepting our invitation to deliver this talk to our faculty as well as faculties from other institutions. I also welcome HODs, staff, devotees, and all the others who have joined this particular webinar, and I also thank them for being part of this particular program. So once again, I welcome you all for this seminar, and I hope this seminar will be very useful for the participants. Jai Shri Gurudev.
Oh. Thank you very much, sir, for welcoming the participants. Now I would like to introduce our today's speaker, Dr. Anush K. Chandrapa. He has obtained his bachelor degree from BMS College Bangalore, and he has pursued his master's from IIT Kharagpur, and he has obtained his doctoral degree from the same IIT Kharagpur. So his research field is he has carried on broad research in his and would like to deliver a lecture on constructional aspects of rigid pavement. So I request our speaker, Dr. Anush K. Chandrapa, to take over the session. Sir, it is okay.
Good morning all. Firstly, I thank the host team for organizing this particular event, and also thank Dr. Ravi Kumar for this welcome note. So I'll just share my screen.
Yes,
can someone make me the presenter? I'm not able to find that option of share screen.
Okay. So can you make him as presenter?
Yes, please. Sir, try.
It is just loading. Is it visible now? Screen?
Yes, sir.
I'll go to slideshow mode. Is it visible? Full screen?
Yes, sir.
Okay. So good morning, participants. So today we will have one small talk on construction aspects of rigid pavement. Now the rigid pavement, regarding rigid payments, I learned when I was working as an engineer in Buildcon Limited. So whatever I'm sharing in this presentation is basically my experiences, what I've learned, and also what I've gained some knowledge about this particular topic. So why this topic is basically, now we all know before we used to see a lot of flexible payments, bituminous payments. Slowly there was a trend or there was a shift towards rigid payments, considering the life cycle cost and also the design life. This is a flexible payment we design for 15 years design life, and this is a rigid payment we design for 30 years design life. So this way the rigid payment was found to be economical in considering to flexible payment, and so most of the roads were built using rigid payments. So while building or while constructing a rigid payment, we should know what are the quality control activities or how to construct those kind of payments so that they can serve for at least 30 years or whatever design period it has been designed for. Now, let's take a small introduction about the payments. So we have two kinds of payments basically. One is conventional payments, what we call, and then non-conventional payments. Because conventional payments, we have flexible payments. Normally it can be a bituminous payment or also an unsurfaced granular payment. And then we have a rigid payment, which is mostly a concrete payment. Then non-conventional payments, we have semi-rigid payments, and then porous payments and paver block payments. And in this non-conventional, there can be different kinds of payments as well. Now, in this presentation, we will limit our talk to rigid payments. Now, the rigid payments, basically we all know that the load transfer happens through slab action. Unlike flexible payments, where you should be having a very good interlock between the aggregates. So here, the action of load is through by slab action. So whatever load will come on the particular rigid payment slab, it is transferred by a slab action. Right? The slab action means it should be having a very high flexural strength. That's why we call it as a rigid. And then it possesses a high degree of stiffness. If you compare the stiffness of a bituminous material or bituminous layer to a PQC layer, that is payment quality layer, it's around 10 times difference will be there approximately. And then basically rigid payments means a concrete payment, as I told you earlier. This is a typical cross section of rigid payments. We have payment quality concrete, which is the concrete slab material. And then we have dry-in concrete, the DLC, which forms a uniform foundation for the PQC layer, and then sub-base for a drainage purpose, and then we have subgrade, right, as a founding material. So now, one thing keep in mind that the PQC and the structural concrete, what we use in different structures like beams, columns, are quite different in terms of composition and in terms of workability. So we will see in further slides. Obviously, a typical payment, rigid payment cross section. So as I told you, we have PQC, DLC, granular sub-base, and subgrade. When a load comes on this kind of payment, you can observe at this point the subgrade is subjected to very low load. So that's because the PQC will take, or the slab will take, the maximum amount of load. The lower layer just provides it a uniform support. So in the concrete payments or in the rigid payments, the support should be uniform. Even if it is weak, it's not an issue, but it should be uniform. Uniform means it should be having the same values of, let's say, modulus of subgrade reaction or the CBR value throughout the stretch, it should be having same. Now similarly, if the same load comes in a flexible payment, we'll see what happens. This is a bituminous payment. We can see that at the subgrade, the load is over a very small area, and also load amount is magnitude is very high. So this way, the PQC will result in a very low load at the subgrade layer, and but bituminous payment may give higher load to the subgrade layer. So now, in rigid payments, we have normally three variants. One is JPCP, that is jointed plain cement concrete payment, which is mostly widely used in India, which is designed as per IRC 58. And then we have JRCP, which is called as jointed reinforced concrete payment. And then we have CRCP, which is called continuously reinforced concrete payment, designed as per IRC 118. Now, mostly as I told you, in India, we always go with JPCP because the JRCP and CRCP are, first of all, maybe quite costlier, and also the difficult to maintain if there is some wrong thing happens during construction or design phase. So now the difference between these three payments mainly are, one is joint and crack spacing, and then amount of reinforcement. As you see, the JPCP is plain concrete, you won't give any reinforcement in the concrete slab. But in JRCP and CRCP, we give some amount of reinforcement mainly to hold the crack, linkage cracks, to hold them tight without opening wide. So, if you see this particular picture here, now this is JPCP. The joint spacing in JPCP, that is the transfer joint spacing, is around 4.5 to 5 meters. Right? If it goes beyond 5 meters, it will be quite difficult to control these kind of cracks. As in the profile, you can see a crack along the depth. So these cracks, if you go, let's say without reinforcement, if you go for a longer spacing or a wider spacing between these transfer joints, a crack can come in between. Right? So to contain or to make this crack tight or to hold this crack tight and then increase the joint spacing, we go for JRCP. If you see here, the JRCP has still a crack in between, but this crack is held tight by this mesh of a steel reinforcement. It can be which we give. But one thing is keep in mind that whether it is JPCP or JRCP or CRCP, for given traffic, the thickness of concrete slab may not change, right? Because the reinforcement what we give in the this JRCP and CRCP won't help structurally. It is just given to hold the cracks tight. So that if these cracks, let's say, open wider, then it will affect the riding quality also, and water can easily ingress and damaging the reinforcement. So this way, the mesh or reinforcement what we give in JRCP or CRCP are just given to hold these kind of cracks tight without opening wider. Now, if you go for CRCP, yeah. Now CRCP you can see a number of cracks, transverse cracks continuously along the road, but these cracks do not open wide, very wide, because we give a reinforcement throughout the length of the road. So whatever length we have, throughout the length we give a reinforcement. So these cracks are held tight. So since the CRCP does not have any joint, so other than joint of construction, so the riding quality in CRCP may be better compared to JRCP and JPCP. But in JPCP, if you see, every 4.5 meter, you will encounter one joint, and if joint is not properly prepared, you may encounter a small bump or something like that if joint is not prepared. And also all these three payments, anyways, will be having joint of construction after end of day's work. So this is the basic difference between these three payments. But today's lecture we will confine to JPCP, because that is what we use in India widely, and most of NH and also SH are built using this JPCP technology. So now in this lecture we will cover some topics about JPCP and its stresses and technique of construction. So how do we lay JPCP, and then design considerations. Before I start, there is one very good saying. I don't know who said this, but it says wrongly designed concrete pavement. Even it will be pavement also, but rightly constructed will perform better than rightly designed concrete pavement but wrongly constructed. That means, let's say you have designed wrongly, you might have left some portion of traffic or some other thing, but if you have rightly built, whatever quality control, whatever practices you adopted are very good things, so it can perform excellently. Right? But if you have designed very well, considering all the parameters, but when you construct wrong, like if there is some issue in the quality and all, then the pavement may not serve to full design life. So before we go, the first concrete pavement was built in Inverness, Scotland, and then in India it was built in Madras. This information what I got from internet or Google. Going for stressors, now we'll talk about concrete pavement. The concrete pavement will be subjected to two kind of stresses or two kind of loads. One is load factors from commercial vehicles or traffic. One is climate factors or environmental factors. So these two factors will affect the concrete pavement at various stages of design life. If we talk about the when we start laying PQC itself, it will be undergoing some different kind of stresses in the fresh state itself. Mainly, the climate factors or environmental factors will affect both the fresh state and hardened state. So it is more critical or crucial than the load factor. That means if you cannot control the effect of environment in the fresh state, the hardened state may be a failure. So this way, the climate factors also play a very major role while constructing a concrete pavement. So we'll see how they will play a major role. Now let's say when you start laying a concrete slab, now this is basically a concrete slab, right? So now when you start laying, it's in fresh in state, right? It's a fresh concrete laid. So now what happens? This concrete will be subjected to sun rays, then wind. These two factors, what they will do? They start evaporating the water. In the top surface, if you see here, the top surface, the water will be evaporated. Due to this, there is a moisture gradient. In the top, there is S amount of water. In the bottom, there is more amount of water. There is some gradient developing in the slab. And second thing, within the concrete, there is a reaction happening, which is exothermic. Exo means out, thermic means heat. So there is a heat release within the heat is being released due to reaction of due to hydration of cement, which will increase the temperature of the whole concrete slab. So due to these interactions, here you see, now there is gradient, there is a shrinkage, there is a reduction in the volume. It's trying to reduce its volume due to loss in water. But parallelly, it is gaining also some strength right? It will apply some restraint. So blue is restraint, it will apply some restraint. So due to interaction of these between these forces may lead to plastic shrinkage cracks, which are the first kind of cracks when we lay the concrete slab. When you lay a fresh concrete slab, if you don't protect them from sun rays or wind, you will see very thin, right? Very thin and widely spread plastic shrinkage cracks. Right now, these are they will look in the initial stage. So, it's a hardened concrete slab. So, this kind of cracks are basically shrinkage cracks, which has happened in the fresh stage itself. The time if it is not corrected, these are the slabs will basically look, right? Now, again, it's also very you can see they're very thin cracks, right? Again, yeah, this is typical how the whole if you don't protect from sun and wind, this is how they will look. Normally, the plastic shrinkage cracks, if you want to identify in the field, you can identify just by looking at the pattern. Normally, they are parallel to each other, this crack, and they're always perpendicular to wind direction. So, why perpendicular? What happens when the wind is going this direction, right? Perpendicular road, shrinkage happens along this width. That's why the cracks will be parallel to each other and perpendicular to the wind direction. This is one way to identify what kind of cracks these can be, if it occurs in the fresh state itself. Other thing, very important thing, right? After plastic shrinkage, much more very rigorous kind of stress is drying shrinkage crack. So this drying shrinkage leads to excess contraction stresses. So what happens as the concrete starts getting harder and harder, it's gaining strength. At the same time, as we lay a concrete slab, when we lay a concrete, normally using slip form pavers, we lay at a rate of let's say around 300-350 meters per day. That will be the day's work. Around we cover around 300 meters per day, length is covered. Now in that during that phase, what happens? The whole lengthwise and also widthwise, it will try to contract because there is a loss of moisture and hydration happening. So and heat wants to come out of the pavement. So all these interactions will make the concrete to contract in both directions. So this is the length direction and this is width direction. So what happens along contraction, along the longitudinal contraction, it is more critical than transverse contraction because the length is more along this particular direction, the red one. As you see here, this particular relation, delta N is equal to L into alpha is delta T, right? So more the L, more change in the length. So along this particular direction, we have more length. So along this direction, there will be more change in the length. More shrinkage can happen. Now to avoid that kind of shrinkage, we adopt some practices of construction which we will discuss. So but this is how these contraction stresses will act in the fresh concrete when we lay a fresh concrete slab. So now when due to these kind of contraction stresses, so what happens? These kind of cracks will occur. Now this is basically a transverse crack which is due to longitudinal contraction. If you don't consider longitudinal contraction at a particular given time while laying concrete, so these kind of full width, right, and full depth cracks can occur in the concrete slab. And these cracks, once they occur, they're very difficult to maintain. First thing because they are random, right? The shape is not straight, or it is a random shape, and then at this particular crack there may not be any load transfer devices other than interlock of aggregates. So we don't have any double bars or those kind of load transfer devices. So over time, what happens? These joints will easily start spalling. When they can start rolling on these kind of pavements, this will start spalling slowly and will become a big, let's say, a wider gap, which will allow water and also other debris affecting the riding quality. Right? So, as I told you here in this relation, delta T. Now, delta T is basically the temperature differential plays a very important role in PQC behavior, even in the hardened state and also in the fresh state. In the hardened state, the fresh state, it will cause contraction stresses. In the hardened state, it will cause curling stresses. So basically, the temperature differential is the temperature at surface, top surface minus temperature at the bottom surface. This is the temperature differential. So normally we assume a linear variation of this particular gradient, but it can be a non-linear also. there are studies where they try to incorporate. There is some noise. There are many studies where they try to incorporate a non-linear relation also. And then even in our IIT guideline, daytime we normally assume non-linear and nighttime we assume linear variation, right? And then this gradient will lead to curling of slabs. So curling means changing shape of the slabs as the temperature gradient changes. So this is what a curling means. So now if you see, this is the DL layer what we place, and this is the basically debonding sheet what we place in the between the hardened PQC and DLC. So debonding sheet is basically used to prevent full bonding between the hardened PQC and the DLC. So what happens in the night time, the temperature at the bottom is high and top is low. So what happens? It will curl upwards, right? It will curl like a bowl. You can see this even this phenomena when you let's say you keep some papad on the hot tawa, it will immediately take a shape of a bowl. That's because the top it is cool, the bottom it is in contact with the hot surface, so immediately it will start curling. Similarly, in the daytime what happens? It will curl in this direction. It is curled downwards. So the center part will lift up, right? Well, edges will be in contact with the DLC. So here the top is a high temperature and bottom is a low temperature. So what happens into this? You see here, this is gradient stress. It's trying to lift up the slab, and here you see here the self-weight restraint. There's restraint from self-weight. So one is trying to lift up the slab, and the self-weight restraint is trying to bring it back to the original position. Due to this, again there is some issue. Then similarly in the daytime also, this is what is trying to, this gradient is trying to lift it upward, I mean from center, but the self-weight will make to hold it in the original position. And due to this, we encounter two kind of cracks, right? What we call, one is called top-down cracking. In the night time, we encounter top-down cracking. So what happens here, when the vehicle starts moving, right? When we see the vehicle is moving continuously, and whenever the axle spacing is less than the transverse joint spacing, they will start cracking at the from top, right? Because load is here and the load is here. At the top, it will start cracking, and this crack won't happen in one go. It will go repeatedly, as shown in the figure. So when one go it never happens, it will keep repeated by repeated action of commercial vehicles. The crack will initiate and slowly they will propagate to down, and finally the whole slab will crack, right? And once this slab cracks, there won't be any load transfer devices between at this particular point, and the whole slab will start deteriorating. On the other side, you see the daytime. Even daytime what happens? The curl is lifted upwards. I mean this downwards, at center is upwards. Again what happens here, the vehicle starts coming. The tension is maximum at this particular point, and it starts cracking from the bottom. So we call bottom up cracking. And again here also it won't happen in one go, but due to repeated application of the loads. So this repeated application of loads what we call as fatigue. So in the design of concrete pavement, we take into account the fatigue effect, right? Or the fatigue phenomena we take into effect. So what is the fatigue thing? Basically what happens in fatigue, we'll apply some repeated loads, right? And the load applied will not be equal to the ultimate strength of the material, right? It will be, let's say, some percent. It can be a 30%, it can be 50%, 60% of ultimate load, and we apply at some regular cycles. It can be 10,000 cycles or 1 lakh cycles. You apply continuously, right? And you will see slowly as you apply more and more cycles, there will be crack initiation, right? Because the material is being losing its stiffness, and then crack will initiate and will start propagating. At some point of time, the material will completely break, which indicates the static life of the particular material. This way, same thing happens to the concrete pavement also. So, due to repeat application of loads, the crack will initiate and propagate, and finally, at the end of design life, it will reach, we are expected to reach to the top or bottom, depending on the crack it is undergoing. So, as I told you, the various stresses occur in PQC. So, we discussed it can be climate factors or load factors. So, the stresses are too high, very high enough to develop crack in the slab without loading also. Let's say you don't apply any load, right? You don't apply any load in the concrete pavement. Even then, a crack will occur if you don't, because of climate factors itself. So, how to reduce these stresses? So how can we control this kind of stresses, right? And how are the stresses considered in design procedure? While designing, how do we consider them? And then what is the role of the procedure what we adopt for construction? So when we try to construct the concrete pavement, so what role it plays in controlling this kind of stresses, or does it play any role at all? Then what causes premature distresses? Sometimes what happens if we adopt a wrong practice of construction, there can be development of premature distresses, right? So how to see? We'll see all these things in a step-by-step manner. So first, let's have a look at H.R.S. Westergaard. So he's one of the father of pavement mechanics. So whatever design we do when it comes to rigid pavements like concrete slab and all equations, whatever we use, so we are basically developed by H.R.S. Westergaard. Going for JPCT construction. So the construction of concrete pavement involves some various steps. One is we lay and compact the subgrade. So compacting subgrade, normally we estimate 500 mm thickness. And we compact in layer by layer. We don't compact in single 500 mm. We compact like 200, 150 and 150 to achieve proper density. And then we have a laying and compaction of granular base layer again, which acts as a drainage layer. And then we have laying and compaction of DLC layer and laying and compaction of PQC layer, finishing, texturing, tiling and joint construction. So all these steps finally give a product of JPCT, right? So when we talk about subgrade and GSD, this will be common for flexible or rigid. There won't be much change in the base layer. So we start with the DLC layer first. So the DLC layer is basically a harsh concrete, right? It's a material where you'll be having, let's say, around 150 to 160 kg per m³ of cement, and with some particular gradation, which is laid in a manner you lay flexible pavement. So whatever equipment or whatever the practices you adopt for flexible pavement, same can be adopted for DFC also. So in the DFC, the most important thing is mix design. So DFC should be designed. That means you cannot just mix cement and aggregate and compact. It should be designed for some particular requirements. So for that we follow IRC SP 49. We normally follow. Now for thickness of DFC is normally fixed as per the IRC standards. Right? For SH and MH we assume 150 mm. Other roads fixed 100 mm what we use for normal construction. So now when we talk about the DLC function, main function is to provide a uniform support for the concrete slab. As I told you, the concrete slab, even though base is weak, it's not the issue, but it should be uniform, right? So if there are some non-uniformity in the GSD or subgrade layer, this will be taken care by the DFC, which provides a uniform support, right, for the PQC slab to rest. And second thing, the width of PQC, the DFC layer is always more than the PQC layer. So these are two things actually. One is in the mechanized construction. When you go for a slip form paving construction, this 0.75 meter actually acts as a platform for the slip form paver track to move, because the slip form paver track requires a very hard and very plain surface. For that, we use this particular extended DLC width to use as a platform for the slip form paver to move, right? And second thing, there are studies where they have shown that the extended DLC base can also have some impact on the reduction in the PQC stress. Whatever stress will come at the edge stress, this can be reduced by giving an additional thickness of DLC. So this is the main reason. One is from the aspect of construction, other is an aspect of the performance. But if you see a semi-mechanized construction or a managed construction, normally we give an additional 0.2 meter only, because in semi-mechanized or managed construction, we mostly use a screed vibrator, we can say, which is has a very small 2 wheels, right? Or in manual, we won't use like screed, but we are using formwork. To place the formwork, we may use a DLC, so it requires some strong surface. But we give this 0.2 meter additional in case of manual or semi-mechanized construction. Now, when we talk about mixed design, the aim of design of DLC is to find OMC and MDD. The same concept as property density, but the compaction effort what we use is quite different, right? So the certain minimum criteria are there for DLC. Talk about DLC, one is cube strength. So we should be having a 7 days 7 MPa cube strength whenever we finalize the design of DLC. Now this strength must be achieved in optimum density and optimum moisture content. So now we'll see how this design is made basically. Specification of cement content aggregate gradation, and aggregate to cement ratio. So these three should be first finalized. I mean, what cement content you want to adopt? Minimum cement content as per IRC is 140 kg per MQ, and as per MOS it is 150 kg per MQ. But yes, you can go still higher if the strength requirements demand. And aggregate gradation is particular gradation given in particular code, and also it can be depend on the contract agreement. And then we have aggregate cement ratio. So what is the ratio of cement to aggregate? And then once you do this, you prepare mixes at various water content, right? And then you develop a density moisture relation, and then you identify the optimum moisture content and maximum dry density. And then whatever is the density and OMC is fine, at that particular density, you will again compact cube and then find the compressive strength. If you achieve in 7 days 7 MPa, then it is the design is finalized. If no, you may have to change the cement content or reduce the aggregate to cement ratio and then rework the whole design procedure. Now, structure of material composition. Normally, we use OPC, which is as per IRC 140 kg per MQ, and as per MOS it is 150 kg per MQ. And the aggregate cement ratio what given by IRC is 14:1, and the MOS gives 15:1. Right? You can also go with fly ash and other SCMs we can add in the DLC. But whenever you add fly ash or other SCMs, the aggregate to cement ratio must be reduced to 12:1. That's what the IRC will recommend, because the strength gain in those materials may be low, right? And then when you doing develop a density moisture relation, so we go with starting 5 to 7% of moisture content. We start with 5 and end with 7. Now in this particular range, we will be able to obtain the OMC and MDD. But we will prepare a cube at different moisture content, as I told you. In compaction, we use a vibratory hammer. We don't use a proper hammer. We use a vibratory hammer, which will basically apply a force of 300 to 400 Newton at this particular using this particular plate area for 1 minute per layer. We compact it normally 3 layers, and will vibrate each layer for 60 seconds, and will finally measure. Right? Hello? Hello? Yeah, okay.
Yes, sir. Yeah, we are able to.
So basically we measure density corresponding to water content. Then we'll identify OMC and maximum dry density, whatever water content we achieve. Yeah, this is how we will finally get one density moisture relation. Once we find this MDD, at OMC and MDD, you will again cast cubes at whatever cement content you have used and find the strength at 7 days, and it should be at least 7 MPa. As told you here, so we require 7 days 7 MPa as per IRC SP 49, and as per MOS it is 10 MPa. The reason why the MOS has high 10 MPa is basically the aggregate cement ratio is quite high in the MOS. So this way there is some change in the strength requirements. So if you want higher strength, you can go with higher cement content. But keep in mind, giving higher cement content may also cause issues with cracks in the fresh state. So, and second thing, once you do all this exercise and once you are preparing for the field, right, all the mix, precautions to be taken while transferring laboratory values to the field. Means in the laboratory you are doing a controlled condition, right? So you will be basically requiring it will be in a closed environment, so there won't be any exposure to the environment. I mean to say no hot sun, no wind and all. But in the field, what happens? You're transporting the mix from the plant to the site. There will be some losses due to evaporation, where the moisture content what you added may change. So in that point, you may have to cover these DLC plus, right, to prevent the loss in moisture. So you can add additional 1 to 2% extra moisture for compensating these kind of losses, so that you will ensure that when it goes to the site or to the particular dumping site, in that case the OMC will be achieved there. Second thing, as told you, the construction what we do is same as flexible pavement practices. We use the same kind of paver what we use flexible pavement, which has a system of auger, a vibrating screed and a hopper. So everything we will use this same equipment for this DLC material. And we also, once we lay, use a particular screed which will give initial compaction, just make it a flat surface, and then we also start with rolling behind. So the rolling is same, rolling passes, the number of passes will be decided based on trial stretch what we conduct before laying the DLC in the field. Second thing, the joint construction. So basically we are conducting a joint. So unlike hot mix asphalt where you can push a material, right? There will be overlap here. Mostly there won't be any overlap because it's a hardened material. So you will basically cut a vertical joint and then you will apply some cement slurry and then place a new DLC layer or a fresh DLC layer. And then once you finish the paving operation, compacting operation, the rolling operation, you will immediately apply curing compound. The curing compound is essential to avoid loss of moisture. What happens is you don't apply DSP and there's a hot sun and a lot of wind is blowing the bit of construction. So the top surface may become too dry and it can become friable. That means it can become like powdery. So to avoid those kind of situations, it's better to apply curing compound immediately once you lay the DSP. This curing compound can be a wax based or a resin based. It should be around 4 to 5 hours, right? It will be holding the water around 4 to 5 hours, and then again you will have to use jute bag curing to avoid this losses. This is curing done using emulsion, right? So even emulsion can also be used as a curing material in the DLC layer. And then once you stop, right, previous construction, you will start the next stage by making a joint of construction so that you may have to bond the next layer and the new layer. So you can add some cement slurry at the joint so that the proper bonding can be expected. And finally, once you lay, you determine the OEM set NTD what you have been achieved in the site basically. For this, what is the reference density now? The reference density, is it the laboratory values or the trial stretch values? Normally what happens, we don't take laboratory values for DLC because in laboratory, since we're doing in a very closed environment, so the density may be quite high. In that case, the same lab density what we achieve, it will be transferred to the field to come up with trial stretch. Before going for a large scale construction, you will do around 60-meter trial stretch in the somewhere near around the site, and then you will achieve some particular density. Like it can be a 98% of lab density or 99%. So that will be the reference density for your further field start large scale construction. That will be your maximum density or density of 100%. So in the field, you need to achieve relative for the field trial stretch density, not the lab density, right? So then, I told you the DLC. So while laying, it can undergo excessive drying, and also depending on the distance from the camp site to the site of construction. If it is too far, what happens? There will be loss of moisture in the DLC material. Even though if you close with the tarpaulin, we may expect some loss of moisture here and there. So to avoid that, there are some guidelines given. If it's 90 minutes, it takes 90 minutes for finishing whole process. Then the air temperature should be 25 to 30 degrees. In this you have to finish. You can have 120 minutes for the finishing process or finishing procedure when the air temperature is less than 25 degrees. So this way you can adopt some quality control and to avoid any loss in the DLC quality. And then there will be special considerations in the joints and the curves. So what happens in the joint and the curves on any other ancillary structures? So in the curve, what happens near the curve, a roller may not be able to move very close to the curve. Right? In that case, you may use a plate vibrator or even a baby roller. So small rollers can be used to compact those edges. The DLC cannot exactly go at near the curve. So you can easily use a plate compactor or a baby roller, and similarly at the joints also, right? So that was about DLC. So now we'll slowly go towards the PQC. Now PQC is the only designed element in concrete pavement. If you see the concrete pavement, whether it can be any other, let's say, higher pavement, right? Mostly we design the only slab thickness. We won't design DLC thickness. It is fixed as per the IRC, and the GS thickness is fixed as per the IRC. So we design mainly the PQC, and this is logical, rational, because the maximum load taking element is basically rigid, concrete pavement, and that has to be designed, right? Unlike other layers where the load transfer to them is very low. So while laying PQC, most important thing is harmony in the construction. So all the steps should be properly interlinked to achieve a very good concrete slab at the end of the day. So basically the steps involve preparation mix at a plant. We prepare the mix at a plant as per the design of mix what is done in the laboratory. Then once you prepare, parallelly you prepare the subsurface. Preparation of subsurface means basically on this PQC will laid on the DLC. So DLC while laying it may be having some dry particles or some friable particles which has to be removed, right? And then you will transport the mix, you will pave, right? You will pave the PQC, then surface finishing, the PQC, then prepare the joint, then you will cure it, then sealant, you will fill the sealant at the joints and then open it to traffic. Now this is the whole process of the PQC construction which should be properly managed. So now preparing mix at the plant site, we know the PQC is a harsh concrete, unlike RCC. Like if you take two M40 concrete, one is M40 RCC and M40 PQC, the slump of M40 PQC will be just 25 to 30 or 35 at the site of construction. In the plant, you may have to achieve 50 to 70, but when it comes to site, it will be around 25 to 35 mm. But if you take RCC, depending on the requirement, it can be 75 mm or 100 mm, right? Like that. So one thing, and second thing between the difference between let's say M40 RCC and M40 PQC is the strength. The PQC requires let's say M40 PQC. The M40 PQC requires a strength of 4.5 MPa at least, whatever the thing may be. But we may not test the cube strength, but the beam strength is very important. But RCC, I mean M40 structural concrete, we go for cube strength compulsorily. Like this. Now, slump, a control factor at initial stage. The slump is very important in the PQC because giving a higher slump concrete in a slip-form paver will be difficult to construct or to lay in the site. So, recommended slump at plant is 50 to 70 mm. But the plant, since let's say your site is far from the plant, then you may have to produce at an even higher slump depending on the transport distance, what will happen. But when you come at site, it should be around 35 mm. Normally, when you produce the concrete at the PQC at the site, at the plant, you will first check what's the density, what's the slump at the plant, and then when the same truck comes for the site, and when you dump the concrete in front of the slip-form paver, again you will check the slump. So that you will have a quality control what was the slump at the plant and what was slump at the site. It will indicate how much loss is there in the slump. And then slump depends on the distance between the plant and site, as I told you. So the design of PQC can be done as per IRC 44. Now IRC 44 refers to three gradations. One is 31.5 nominal maximum aggregate size, 26.5 and 19 mm. So basically in most of construction, 31.5 is preferred because this particular concrete gradation requires less cement content. Right, but if we go for this particular 19M, it requires very high cement content. It's around 400 kg per m3. This high cement content is very difficult to control in the field. When you add so much of cement content, you cannot control the kind of cracks that occur while laying PQC. So mostly 31.5 is preferred considering the performance and also the cement. So cement content, if cement content is too high, it's also bad. If it is too low, it's also bad. So this particular gradation gives an very balanced cement content which can be easily maintained or controlled at the site under field conditions. And then you can also use, as I told you, admixtures, fly ash, silica fume, metakaolin and PGBS. These materials can be added as a replacement for cement so that we can achieve some amount of sustainability, and also they may also improve the durability of the concrete over long term. So by adding fly ash, you will not obtain an initial very high strength, but in terms of durability and workability, it can be better. So and then going for the PQC mix design, I won't go into more detail. So normally we talk about concrete design, we target some flexural strength. So we'll be targeting, let's say, some particular strength. So to achieve a characteristic flexural strength of 4.5. So 4.5 is what we use as an 28 days strength. That is the characteristic flexural strength. But while designing, we target for a higher strength with assuming some standard deviation. It will be characteristic flexural strength plus 1.65 standard deviation. This value is what we normally use for M40 concrete. If you use this value, it will be around 5.6 MPa what we need to achieve as target strength. And then going for the components of PQC mixed plant. So mixed plant is where we produce the PQC, right? So the capacity of single plant can be 120 m³ per hour. It can be even higher depending on the agreement of contract, or depending on the contractor's capacity. It can be even 240 m³ per hour also. Now the 120 m³ per hour will be giving around 80 to 90 m³ per hour, considering the efficiency of this single plant. So it won't always produce 120 m³. Obviously, there is some efficiency, loss of efficiency. It will be 80 to 90 m³ per hour. So then we'll be having a cement silo, which is having the cement, then pug mill to mix the concrete. Then chilling plant we have. Then we have dumpers. Then aggregate stockpiles. Dumper capacity or what we call tippers. Normally the capacity is on 8 to 9 m³. What they can carry. So for 1 hour, around 9 to 10 dumpers may be required, right, to finish one batch of single plant. So this is typical tipper or dumpers. And then going for the aggregates. Now when we talk about the concrete constituents, so we have aggregates, we have cement, we have water, and there's some admixture. So all these things will play a very important role in the final product, right? Talk about aggregates. Now aggregates, you normally you place like a stockpile of different sizes, like 40 mm down, 20 mm down, 10 mm down. So now these aggregates are exposed to the atmosphere. Now when it is very hot, right, let's say midday or normal days, so the aggregate temperature will be around 40 to 50 degrees, right? So now this high temperature can certainly affect the fresh behavior of concrete. What happens when you add this 40, let's say 50-degree aggregate temperature in the mixing plant, and at the same time, normally the cement what you get in the site, it will be in the form of a bulker. You won't use cement bags, but you use directly from the plant. You bring the bulker, big bulker. The cement will be loaded in the bulker. So they also will be very hot, like 50 to 60 degrees temperature of cement, because it directly came from the clinkers. So now when these 50 degrees cement and 50 degree aggregate when combined and produce a concrete, the concrete will be much more high temperature because it is releasing heat while hydrating. It can be on 60 degrees. At this high temperature, the concrete can easily undergo shrinkage cracks. Right? I told you the high temperature of materials means concrete will be having high temperature. Now high temperature of concrete leads to plastic shrinkage cracks and harshness. So very difficult to control this kind of concrete. Then second thing, high air temperature plus high wind velocity and low relative humidity are very favorable for shrinkage cracks. Right? They are like close friends to cause shrinkage cracks. So like that, the worst case is hot concrete, hot air temperature, hot very high wind velocity, and low relative humidity. The concrete will easily fail, which you cannot control in the field. Even if you pave, immediately to show a crack as the paver goes forward. So there are some guidelines in experience. Normally the concrete temperature should be less than 30 degrees. So when you bring at the site, when you pave, it should be not more than 30 degrees. Second thing, while paving, temperature of air should be 35 degrees or less. Less is always better, and the wind velocity must be less than 15 kmph. Now these three things should be really or correctly ensured in the site while paving the concrete pavement. If any one of this is exceeding, there is an issue with the quality of concrete, which will be difficult to manage when it gets hardened. So this is a typical graph which given by many organizations like FHW and all, even IIT also has this similar graph. So this will give an idea what will be the loss of water, right, per kg in terms of kg meter square per hour. This will indicate normally it should be less than 1 for a good quality concrete or good traditional environment. And then if you see here, so at site we are using less than 30 degrees per hour. So how do we endure this temperature when cement is hot and aggregate is hot? So how to endure PQC temperature less than 30 degrees? So how do we normally in the site? Normally what we do, we can add moisture to keep the aggregates cool. But certainly we may have to consider this moisture while doing this design. So whatever you add, those will keep the aggregate wet or cool. So it can lead to excess moisture in the concrete. These things should be taken into consideration while producing the mix in the site. Second thing, the plant has chilling plant. A chilling plant will produce a lot of ice. Now this ice chunks can be directly used in water to produce the concrete. Right? This way we can bring the temperature of concrete from 60 to 30 degrees or less. Right? And second thing, once we do this part, we can use simple equipment or handheld equipment called anemometer, which is available at a very lesser cost. So this will give a idea of the temperature of air, wind velocity, and also wet humidity. You can see the reading here at 28 degrees, then 60% relative humidity and 5.2 km per hour. This way you can maintain a good quality control at the site while laying the concrete, and these values can be recorded. Right? You can record the values while laying, so that we will maintain some good record, and we can use these records in future to know what can the reason, what could be the reason for a particular distress if something happens there. And then once we do all these operations, like let's say the mix is ready now, so we prepared a mix. Now next step is preparation of subsurface. As I told you, now subsurface is a DLC basically. Now DLC will be having some foreign particles like waste aggregates, some dust, some debris of construction. So all these things should be properly cleaned. Right? It should be made very clean. And then for this we can use a compressed air. We can use compressed air to blow all the waste material. And then also can pour some water. We can make it damp. Right? Once you prepare subsurface. So once you do that particular damp thing, then what you will do? You will place a debonding sheet on the DLC. Now this debonding sheet, as I told you, will prevent the bonding between PQC and the DLC, and to have a very clean surface. So we clean the DLC surface so that we can place the debonding sheet. If you don't clean the DLC, what happens? Even if you place debonding sheet, it can puncture the debonding sheet. So to avoid this, to properly clean the DLC and make it damp before placing the concrete. So, and then once you place debonding sheet parallelly, we will fix the string line. A string line, as per the required level of PQC, thickness of PQC, whatever is required. It's a very important aspect, the string line. So a string line acts as a guide for the paver. The paver will be having, yes? So paver will be having two sensors on the either side, which will be resting on this kind of string wire. The string wire is very tensioned. It's tensioned tightly, right? It should not be suspending. It should be tensioned, and then you will place this DLC sensor, PQ pump sensor on the string line. So basically, the spacing between these this particular pegs, right, whatever you use here, hinge, this will be around 10 to 5 meters, right? So lower spacing is better always. So it will be having less suspension of the string line, and the string line should be checked regularly for proper tension while laying the PQC. So now this is what will happen here. Now before transporting the mix to the site, we once ensure the slump at the mix plant. Then once it comes at the site, right, it will be dumped in front of slip pump paver. Then once it's dumped, it will be dumped.
Correct enough.
Huh? Sorry?
In better certification go to faculty when.
Sir, go ahead.
Okay.
So please kindly keep it.
Okay. So this is this.
So kindly keep it.
Now this basically.
So are you able to hear?
Certificates faculty అందరూ తీసుకుంటున్నారు కదా సార్ కాలేజెస్ అది తీసుకోవద్దు అలా
He just sir, 1 second. So just start
Okay. Yeah. One second.
Okay, sir, go ahead. You can carry on.
Yeah, when the skipper or dumper will dump the PQC, it will dump it in the form of a heat. So this heat will be distributed over along the surface using a backhoe or a JCB, what we call. So once we lay this, at the same time we can also check the PQC at the site. At the site we check the slump of the PQC. Normally it will be less than the slump at the site, the slump at the plant. So now, as I told you here, now if you see here, the skipper or dumper is directly moving on this debonding sheet. So what happens due to continuous movement? So again, the JCB will move on the same sheet. Due to continuous aggregation, deceleration, and all, the debonding sheet can undergo puncture or it can get completely ruptured. So this will violate our assumption, whatever assumption we assume this is as a debonding sheet, and the PQC and DFC may get bonded. So when these two metals get bonded, the stress profile will be very different compared to unbonded layers. Now, to avoid this, normally what we do, we can give this kind of tracks. Normally we give this kind of track where the dumpers will use this track, and also JCB will also use this particular track to spread the mix in front of the slip-form paper. Right? Even if you can use it, if you don't have particular tarpaulin track, you can use good tracks also for this particular purpose. And then going for the components of PQC frame. Now let's say everything is ready, concrete is ready in front of the slip-form paper, everything is ready. So we have PQC paving frame. So why you call paving frame? Because it's like a what to say? There's all three components: the slip-form paper, the mason trolley, and the texturing curing machine. So going on particular harmony, right? They go together, and each one unit has some particular function to play. And we'll see the thing. Let's see this Mumbai-Pune expressway basically. And this expressway was first slip-form paper exhibited powdered in India, right? Here, if you see, once I was talking to Dr. Engineer R.K. Jain, who is the engineer from Sonipat, Haryana PWD. So he told that this particular pavement was built lane-wise. You see, there are around 3 lanes. It was built first lane, then the second, then third. So they built lane-wise. But nowadays, all pavers like they build all 3 lanes at a time. So due to confidence or technology advancement, so all the 3 lanes they can be built at a time, right? Then components of slip-form paper. Now slip-form paper has few important components. One is spreading flow. Then we have vibrators. Then double bar inserters. Then tie bar inserters, oscillating beam, and super smoother. Each component is very important in proper functioning of slip-form paper and has individual functions to play. And with the spreading flow, now once you spread the mix or heap, when you break the heap in front of slip-form paper, this spreading flow will spread the mix to the even surface in front of the slip-form paper. So this spreading flow will basically move to and fro, and some papers may be also having auger system. There will be auger, what we use in flexible pavement auger. Same auger may also be having in this kind of slip-form paper, but mostly spreading flow is preferred. So and then you can see this will move to and fro, spreading the concrete mix evenly in front of the paper. So and then we have important component is vibrators. So once this spreading flow spreads the mix in front of PQ in front of slip-form paper, the slip-form paper slowly will be moving right at a 0.5 to 1 meter per minute speed. Slowly it will be moving in right. So it will be dragging the concrete inside. Right, concrete is going inside the slip-form paper. So at the same time, there are a series of vibrators. If you see this thing, the wires, the hydraulic systems, this is a vibrators which will vibrate the concrete continuously and will give the particular required shape. Right? Let me show this particular photo here. So this is the particular plate, slip-form paper plate, which will be giving this particular shape for the concrete slab. These plates. Yeah. Now these are vibrators what we see here. So these vibrators will be vibrating at a amplitude of around 8,000, 10,000 impulses per minute. It's a very huge vibration we can say because the mass of concrete is too high. But if you go very high vibration, it's a problem. If you go too low, also it's a problem. Let's say if you go very high vibration, if you limit from this particular maximum limit, what happens? Due to over vibration, the whole cement paste will move upwards and all the force of it will go downwards. There will be segregation inside the concrete, but you cannot see from the top, right? So this kind of segregation, over time what happens, we can easily see parallel lines, right? Behind the paper, as it starts slowly hardening, we can see parallel lines continuously wherever this particular things are placed, vibrators. So these parallel lines are called vibratory trails. So this is very dangerous, right, or very risky from the functioning point of view and also structural performance point of view. What happens? This trails will be having at the top very high cement content and very like a mortar, and the bottom all aggregates have settled. Due to this, over time this particular trials will form a longitudinal cracks, continuous longitudinal cracks, and will damage the concrete pavement. Similarly, if it is too low, let's say, it will not get proper vibration, right? So which will not give proper strength for the concrete. If you want to study more about this, in USA, Iowa DOT, they have done very good work on this particular aspect, right? So one can refer their documents on vibratory trials from Iowa DOT. They have done very good work how this will happen and how it can be prevented. Normally, the preform pavers will be having an online vibration monitoring devices. They will be having this particular device that they can check. So, what is the vibration happening at this particular point of time? Then next is dwell bar inserters. So, as we know that in PQC, I mean concrete pavements, we give dwell bars as load transfer devices. So, these dwell bars are basically inserted, right? They are not placed before the concrete. Sometimes they are placed when you go for manual construction, but when doing this preform paving construction, now they are pushed inside the fresh concrete. You see this particular assembly. This assembly is called as double bar inserters. So each slot, what you see here, has a double bar, and this particular port will push the double bar inside the concrete. These are marks made by the pushing double bar, and this mark, whatever is being made, is covered or further closed by this concrete by the oscillating beam. This way, the double bar inserters will insert double bar at required spacing and at required depth. And also, this particular it will also vibrate while placing the double bar because it has to loosen the concrete. Because it has to push the double bar to at least d by 2, that is thickness by 2 depth. So it should vibrate and then push the double bar. Right? There will be 2 ports on either side. And then we have this again double bar. Now double bar, if you see, double bar a very important element of PQC because they will act as load transfer devices. Sometimes what happens, you can see these 2 kind of double bars I'm showing here. One is, here is the surface. It is very blunt, right, and it has some projection. You see here, it's very flat, plain and very clean. So these kind of double bars will create problems for inserting, right, and it may affect the progress of SPF, and also it is very difficult, I mean it will hamper the proper function. So this is basically done by hydraulic cutters, which should not be preferred for double cutting. This is done by electric cutters, electric blade cutters. This will cut the double bar by applying a pressure, I mean shear pressure. So you can see this projection. There is some extension on all double bars, but here it's a blade cutting. Normal what is hacksaw blade we use, so we have very plain surface. These are most preferred for the double bars. So and then we have a close view of this particular double bar inserter. See, the double bars are placed here, and if you see, double bar has some blue color plastic covering is given. It can be a plastic covering, right? And then the plastic covers are also taped. This cellophane tape or normal cello tape, what we can use to prevent the spirit paste going inside the gap between double bar and this plastic sheet. So now this will be inserted. Now when we insert, this is how the construction will look. So here if you see here, this is basically a plastic sheet under the double bar, right? So this is the cutting what we will make after hiring, and this is the typical view how it looks like double bar. It's placed at a depth of d by 2 is the pitch normally. And then the one of the very important thing in double bar placing is misalignment. So the double bar misalignment is a very risky phenomena because once you place double bars, you cannot see how they are placed, right? They are inside the concrete. So concrete is opaque. So you cannot see are they parallel to the normally the preferred condition is parallel. They should parallel to each other and parallel to traffic direction. It should not be there should not be any skewing or any transition. If you see here, now when you place double bar, right, we assume it is placed, but how it is placed? Is there some skew? Is there some movement? Or all those things should be taken care. So what we do, we see here the typical misalignments. What can happen while placing? So this is horizontal transition. This is longitudinal transition, right? And this is vertical. This horizontal skew. You see, this is double bar here. This is placed at wrong position. And again, this is vertical transition. That means you're placing at some other depth than the required depth, and this vertical tilt, right? So all these kind of misalignments play a very major role because they will affect the joint movement. Since the joint may undergo some movement due to thermal changes, so if there is some this kind of misalignment, they will affect the joint movement, and the crack can occur even in the fresh state also. Also some case study what we have done. So there you can understand. So here normally IRC 15 gives the particular recommendation. So Q they limit to very low value, less than 10 mm, because Q is very very damaging compared to other transitions. So they limit only 10 mm, and longitudinal shift can be 50 mm, like less than 50 mm, and vertical transition up to 25 mm, like up or down. This is a very important effect because if you, let's say, you put this double bar too high, so what happens when you cut a groove? We will come to the point. When you cut a groove, you may cut double bar also. When double bar is cut, the load transfer device is damaged, and there won't be any load transfer action between the two slabs. So this way, this particular alignment should be checked regularly, but this checking is difficult. This requires normally an MIT scanner. So it's a scanner which is even you can use GPR also. You can normally they use MIT scanner to see how this double bar is positioned inside the concrete pavement. Now we'll see some simple case study what we had done. So now you can see here we had one crack, right? We had while laying concrete pavement, we saw some cracks, right, at joints, which was regular intervals, right? Wherever it says double bar, so we saw some cracks. So we anticipated some issue with the double bar placement, so that we can correct in the next set of construction. So what we did, we just saw the crack, and since we know this crack maybe it's double bar, we took two cores. So we know the length of the double bar, so we know the double position. So we took two cores opposite to each other. So one core here and other core here. So that the length of double bar is covered in the particular core, and when we took the core, you can see a crack was there. It's a full depth crack at this particular point, and crack was not further extended. Only where double bar was there, at this point crack was there. You see here. So then we took a core, then we found some points, right? One thing you can see here, double bar has some vertical transition, right? This slab thickness was around 280 mm. It was not at 140 mm, but it was quite down, right? There's a vertical shift was there. And second thing, when we took two sides, like this one side and the other side, if you see here, there is some skew also, right? So both are same thickness, both are same double bar you see. Now these are the lower level, these are higher level. That means there is some skew. Skew has happened between these two. There is vertical skew has happened. So you see here, this is the bottom surface. It's not pointing on the other end. So this way we found there is some skew, and when we drew this particular diagram or a cross section, it was placed 155 mm, not at 140 mm, and if you see other things, it was at 153 and it is at 155. There is a skew of 2 mm. First of all, skew of 2 mm was there, and there was some vertical transition also was there. So this way, this kind of misalignment might have caused this kind of crack. So basically, later we have to completely remove this whole joint and replace with new set of double bars. So this way is the one method where we can use this field method to identify the misalignment. Certainly, it is destructive. That means you will take a core, it can damage the concrete, right? But if you have some doubts in the field, if you want to clarify some without using MIT scanner, by taking some simple code, you can also use this kind of methods, a field method where without using any MIT scanner, because MIT scanner is quite costly. It's around 80 to 90 lakhs it may cost. So this way, this kind of methods can be simply used with the field to see is there any alignment. If these cracks are not because of double bar, then you can find other reasons why these cracks might have occurred. From this we got to know this is because of the double bar. So if these cracks are not because of double bar, if there are proper alignment maintained, then there can be some other reason in terms of concrete mix issue which can be further corrected. So then we have tie bar inserters. Similarly, double bar inserters or tie bars hold the two slabs in position, right? So they won't move away each other once you give a cut. Tie bars are basically a TMT bar. If it's double bars are smooth bars. That is, the surface is smooth. There is no rips or any projection, so that it should be very free. It's not bond with the concrete. That means at the double joint, the concrete can move easily. It expand contract. But in tie bar, it is a TMT bar, a ribbed bar, which will be bonded to the concrete to hold, which will hold the two slabs together. So again, we have this particular oscillating beam as I told you. So whatever the marks made by tie bar inserters and double bar inserters will be covered by this oscillating beam. This oscillating beam will, in this is the oscillating beam, this will move to and fro, right? It will move to and fro like this and collect the thin paste, and slowly whatever is collected will start covering this particular spot. Basically, if you don't cover this spot or if it is not covered properly, this will be reflected on the surface very soon. I'll show some other distances where you can see this kind of tie bar marks, double bar marks, which will later convert to a pothole, affecting the riding quality. So this is very important to see that it won't damage, it won't, the marks are not seen once this concrete is filled. So this basically should be a very cement based of thing, so that it will fill all the void made by this tie bar inserters or double bar inserters. Finally, we have this super smoother. We have super smoother. Finally, it will act like a what to say? It will give a finishing surface for the PQC by using the cement paste whatever we had. It will make a very finished surface covering all the whatever there were irregularities. So all will be covered by this super smoother, right? So then once we do super smoothing, whatever we do, we see it will be very smooth surface, right? All the cement paste is on top surface, right? So this will affect the riding or skid resistance. So to improve the skid riding quality or skid resistance on the surface, first thing what we do, we go for a texturing. So the texturing is done using a mason trolley. So mason trolley is one of the component of PQC train, where this will be a platform for the mason to stand, because since it is, let's say, this is a wet concrete and one cannot walk on this, and if there is some irregularity which will be corrected here, one cannot walk and correct it, it will damage the other concrete. So this mason trolley provides a platform where the mason can stand on it and he can correct wherever this particular irregularity or things are there. So if we have some wheel, it can be pushed manually, or some can be also used motorized mason trolleys. So also, where mason trolley we give jute bag. Jute bag will take excess paste from the surface and give this particular rough texture. That means it will expose some sand and cement mortar on surface, so that we get some texture or a rough surface, and this further will be improved by texturing curing machine. We'll see how. So this is called texturing curing machine, which is behind the mason trolley. So this texturing curing machine basically will have two functions. One is curing, other is texturing, or we call it as timing, right? These are typical TCM. So now, surface finishing of PQC, the two steps, one is texturing and timing. This is what we call texturing. Then this is called as timing. The TCM or texturing curing machine has this brush. So this brush has wires which will just move to and fro, right, on the brush concrete and create this timing. Now this timing, once it gets hardened, it will remain permanently, and this timing should not be done immediately after laying PQC. At least a gap of 30 minutes should be given, because if it time immediately after laying PQC, this mark can get closed, because it will be having like high smell, or like the paste has some tendency to flow, it gets closed. So give a lap of around 30 minutes, then we can start timing operations. Right? So this is the timing, and then the timing pattern also matters a lot. Normally, this is the timing pattern. Typical pattern given IRC 15, if you refer. But this pattern, the spacing is irregular. This spacing is less and this spacing is more. They are not evenly spaced. The time brush are not evenly spaced. They are spaced at some random pattern. This is to avoid the wheels, right? The vehicle wheels. Undergoing uniform contact, right? There is some random spacing between the timing marks, and then also you can time manually also wherever you cannot time at the places where this TCM cannot go. So you can time using manual brush using this timing, but the quality of manual brush may not be obviously equivalent to the brush timing made by the TCM machine. And this is application of white curing compound. So once you do all these activities like timing and all, you start applying white curing compound. So because as I told you, the curing compound is very important because the concrete is fresh and you cannot do curing water curing immediately, or you cannot place semi bags immediately. So, but it is exposed to the sun, wind, and all those factors. So to prevent the water evaporation from the surface, you go for curing compound. You apply curing compound using this particular spray. It has a spray. This is all the curing tank, curing compound tank. This is the curing spray. This will move to and fro, right? And apply this. Apply the curing compound evenly. The curing compound can be a wax based or a resin based material, right? Also, this TCM has a side phase curing. That means they can cure sideways also, because curing is going on sideways both. Wherever the concrete is exposed, you have to spray curing compound to prevent any differential shrinkage that may happen in the concrete in the fresh stage. So let me show the other curing. Then once you do all this operation, once you cure, you will allow it for, let's say, 4 to 5 hours, right? Because so that it will gain some strength in a particular period of time. So as it happens, it will prepare for the joint construction. But joints play a very vital role in the PQC. It's also an important aspect in the PQC where one should give very vital importance for those. What happens? Joints in PQC are basically induced cracks. As I told you in initial slides, the drying shrinkage cracks will cause full width, full depth transverse cracks. Right? But those cracks are uncontrolled cracks. Now in JPCT we give a joint, then these joints act as induced cracks and also a controlled crack, right? Unlike in complements. Now we have three kind of joints in PQC. One is contraction joint, contraction joint, and expansion joint. Normally the expansion joints are not given in concrete pavements. Mostly we give only in places where a concrete pavement abuts a bridge, where there is a bridge, where the PQC road and the bridge are meeting at some point, then we give this expansion joint. Other than this, we never give joint of expansion because they will affect riding quality very much. Normally we give two joints, contraction joint and joint of construction. So these both can be either transverse or longitudinal. So I told you, each joint has some specific function and requirement, right? So they play a very important role with some specific function which they will satisfy, and both joints have some requirements to be satisfied. Now let's go for a joint of contraction. The contraction joint provided it can be given both directions. One is transverse, other is longitudinal. Purpose is what? To allow free shrinkage of PQC. So as I told you, the drying shrinkage will basically cause contraction stresses. Now to avoid this contraction, to build up more and more stress in the PQC, right? Before the drying shrinkage can take over the concrete strength, we give this kind of contraction joint so that whatever the cracks will happen at the place where you give a joint. It means we are trying to weaken, or we are creating a weakened plane in the concrete slab where this drying shrinkage can be satisfied. So this way we try to give this controlled crack. So the requirement is at the transverse contraction joint we give double bar, and the longitudinal contraction joint we give tie bars. This is the requirement for these two joints. And joints are prepared by cutting grooves at predefined positions. So whenever while laying the PQC, we will mark some positions on the shoulder side, on the DLC side, where this joint should be given, because that's the point where you will insert double bars. So you need to mark those positions, and after 4 to 5 hours of laying PQC, at those points we will start cutting the groove. So transverse contraction joints stress are higher than longitudinal contraction stress. As I told you long back, in the previous slides, the transverse contraction, which is basically the longitudinal, happens in longitudinal direction, is more than the longitudinal contraction stress, which happens in transverse direction, right? Because the length is more in transverse contraction stress, while the length is less in longitudinal contraction stress. So now there is a typical transverse groove cutting. The groove cutting is also very important task, because that's where you create a joint. But here we should be very careful here. The laborers who are cutting the groove, they may not be aware to what depth to cut the groove, like all these things. So now sometimes what happens, I've seen many times, when you go for field visit, they should cut the tie bar also and double bar also, because they used to don't know what depth to cut. So whenever you see a spark coming regularly. So when this blade is inside the concrete and when it is cutting the concrete slab, so whenever you see a spark coming regularly, that means it's cutting the dull bar or tie bars. So this spark is because the bars are being cut by this blade. Whenever you observe, just ask him to lift the blade upwards, and you can see the double bars, tie bars are being cut. This is answer groove cutting. So the question is when to begin groove cutting, right? And how to cut the groove and what checks need to be made, right? So first question is very important task is when to begin groove cutting. To talk about groove cutting, the first aspect is we have something called as groove cutting window, right? So in the initial stage, the concrete is you lay a concrete and slowly it will start hardening, right? It will start gaining strength. So parallelly, there is also development of contraction stress or shrinkage stress. So both are going hand in hand. One is it's hardening on one side. On the other side, there is contraction happening, right? If this contraction strength exceeds this hardened strength in the first stage, it will easily crack. The concrete will crack like in form of transverse crack, full depth, which is form uncontrolled crack. So before this drying shrinkage or contraction stresses exceed or take over the concrete strength, we should cut the concrete so that it can be satisfied. Okay, we have vacant a plane here, you just crack below this vacant plane. So in this way, we satisfy the contraction stresses. So that we need to identify the groove cut window. A groove cut window is a window where you can cut the groove so that you won't damage the concrete. Now the groove cut window is normally 4 to 5 hours or 4 to 6 hours in summer and 6 to 8 hours in winter season. But this certainly depends on many other factors. But in general, we adopt 4 to 6 hours in summer and 6 to 8 hours in winter. So higher temperature, you have the groove cut window will occur very early. It's a very hot temperature. You have to cut within 1 to 2 hours, let's say. If it's very cold temperature, we can extend the groove cutting time for let's say 10 to 12 hours also. Now in addition to this groove cutting, right? So yeah, I will tell one more thing. Okay. Now groove cutting time corresponds to time when drying shrinkage stresses at maximum. So it means the groove cutting time is where you should cut the groove at that particular instant so that the drying shrinkage are satisfied. Normally we adopt this time, and time is influenced by various factors, as I told you. Now in this figure we see the early cutting causes raveling, late cutting causes cracking. Now groove cutting window has two ways to be identified, can be seen in the field. One way is that when your concrete slab, right, has the capacity to take the weight of the groove cutting machine. So whatever this machine is using here, right? If the concrete slab is strong enough to take the machine weight, you can start groove cutting, right? On the other hand, if the strength of concrete is 2 to 5 MPa, even then it's a good time to start the groove cutting. So that's what you can do. You can just do the cube strength at different time intervals, right? And then see at what time interval you will get 2 to 5 MPa strength. Other time interval you can start, which is the groove cutting normally. But the best way to identify is that it should be able to take this particular weight of the machine, waiting, and then yeah, in summer I told you normally 4 to 6 hours that's where you will cut the groove, right? After laying between 4 and 6 hours you will cut the groove in summer, and after laying between 6 and 8 hours you will cut the groove, right? Now this is what happens if you cut late and cut early. If you cut early, what happens? The concrete is still hardening, right? It's not too hard, and when you insert the blade, right? Let's say concrete is able to take the machine weight and start cutting. So this cutting blade, what is using here, the cutting blade will start picking the aggregates. So whatever aggregates are there and the concrete, it starts picking it. So when it picks, it will also bring some chunk of concrete upwards. So this you can see this kind of large big marks near the joint, and these kind of marks, right, can slowly develop into spalling over time when we open for traffic. This way the joint quality will be damaged, right? So that you should identify proper time to cutting. And second thing, if you cut late, so if you cut late, it's too late that crack already has been occurred at some other spot where you plan to do groove cutting. So it's a full width, full depth transverse crack. So where you don't have any load transfer divisors inside it. So this way it is it's very important to identify a typical groove cut window. So there are some guidelines as I told you. Now next thing, once you identify groove cutting, next thing how to cut the groove, right? So it's a very important fact. Normally a groove cut or cut the depth of 1/3 the slab depth. So let's say 1/3 or 1/4 also, but 1/3 is more preferred. So normally the slab is 300 mm thickness, cut the groove up to 100 mm. So cutting depth is a very important factor. Let's say if you cut to 60 mm, okay, I have cut to 60 mm, it's fine. Even then it is not fine, right? It will still won't give proper weaken plane for drying shrinkage to be satisfied. So it is always better to cut to depth of 1/3 to be on safer side, and also it will weaken the plane sufficiently. So if you go deeper, let's say why don't we cut D by 2? If you cut D by 2, you'll cut the double bar also, right? So there is tie bar and double bar at this particular depth of D by 2. So if you go deeper cutting, you'll be cutting double bar and tie bar also. So to avoid all these things, so 1/3 of thickness of slab is sufficient to create a weakened plane in the PQC to satisfy the drying shrinkage stresses. Yeah, normally this spacing what we adopt for groove spacing, transverse groove cutting spacing is 4.5 to 5 meter in transverse and longitudinal 3.5. That means one slab size will be 4.5 meter and 3.5 meter. Similarly in JRCP it will be 7.5 meter into 3.5 meter. So in JRCP we can go for a longer spacing so that we can have a better riding quality, but you may have to place a mesh or a steel reinforcement. Yeah, now one more important thing is in the groove cutting, let's say you cut the groove up to this depth of D by 3 and this is a double bar, right? And it's a plastic sheet what you will place inside the double bar, and this will cut the groove. And now if this plastic sheet is extended beyond the cutting phase, then it is safe, the crack can generate just here. And let's say you have still put a plastic sheet, right? But it is not of a length which should extend beyond the joint phase, then the crack won't occur, because there are chances if this double bar is rusted or it has some surface irregularities, the bonding can happen and the crack can occur somewhere here or somewhere here, depending on the stresses. So this also plays a very important role in generating a crack below the groove cut position. This is how a good groove cutting will look like. When you cut a groove, you should see within 1 or 2 days typical crack like this kind of hairline crack. So this hairline crack may not occur in all the groove cutting. Anyway, you should do groove cutting at every 4.5 meters, but initially it may occur at every 9 meters, right? So then later when traffic starts repeating, when you open the traffic, then this can occur at a closed interval. So, but thing is that it will weaken at every 4.5 meters, will give this kind of groove cutting. It is normally 3 to 5 mm wide and depth is D by 3. So, it is a good sign that the stresses have been satisfied and further crack won't occur because of shrinkage in other positions or other locations in this particular slab. Again now, what happens if you cut a groove? Let's say you have still cut a groove but not a proper depth. But this is a typical 300 mm concrete core, right? Now let's say you have cut a groove, right? The labor has told us you have cut the groove and engineer has changed and no groove is cut. But now this is the groove cut is around 40 mm groove was cut, and this is totally equal to nearly 100 mm groove cut. See here, below this groove you can see a crack. That means the shrinkage has been satisfied. But if you see here, so the groove cut is there, but there is no crack here. So actually in this particular slab, the crack was at some other position. Like it's uncontrolled crack had happened in this particular slab. So it means what it indicates. So even if you cut a groove, right, it should be for a proper depth of D by 3. If it's not D by 3, if let's say it is other than let's say D by 5 or D by other thing, so it will won't weaken the concrete sufficiently, and the crack can occur in some other position where you may have to further repair the concrete or replace the concrete, right? And then we have finally At the end of the day, you can also tell a labor who are cutting the groove to check it regularly, so that he can, if it is not cut to required depth, he can cut it once again to required depth, so that he can ensure that the concrete is cut for a proper depth. Because once these kind of shrinkage cracks occur, I mean drying shrinkage cracks occur, it's very difficult to repair them because the uncontrolled cracks. Our only option is to remove and replace the slab once again. And next part is, once you do all this cutting, everything is done now. Next is curing, right? Once you cut, right, after 8 hours of laying or 6 hours of laying, you start curing. The curing is also a very important aspect, and we need to adopt some sustainable practices. Why? Because let's say we are paving the concrete pavement in the place of Maharashtra, where it is very arid region. Let's say like Nagpur or some, let's say like Solapur and all. Now, those are very hot, where water scarcity is too high. Right? And in those days, if we start using water from borewell, which is used for drinking, for curing concrete, it's a complete loss of water. Right? And second thing, so whenever you pour the water on concrete pavement, so you see that water won't stay there. Like this flows, because they are given a chamber. It just flows. It will just wet the concrete. Like it won't stay there for a long time. It will just wet the concrete and just flow and then come out along the shoulder, and it will be making a stagnant water at the shoulder side. It is complete waste of water. So this should be one should basically check is the practice correct or not. So there are many other methods where you can adopt some sustainable practices. So one way is, in the initial stage, we'll go for this kind of curing, that is resin-based curing. We'll apply, and as you can see, this is sprayer, this is spraying curing machine, and this is side-based curing, right? And this is a debonation you can see, and it will spray on the sides also to prevent any differential shrinkage. And then the next part is, after bull cutting, you will cure it for 28 days, right? So here you can see. So what we try to do in some places was, so we had a lot of resistance from the localites. So it was the building some highway in Maharashtra. So there was a complaint from people that they are using water unnecessarily. Right? We also know that whatever we use curing concrete, so it will basically just pour, it will flow on the sides and it will be standing here, like stagnant water. It's a complete loss of water. So we try to work on whether can we adopt, okay, membrane curing or debonding sheet. This is basically debonding sheet what we use. The same sheet was used as a curing purpose. What you basically did, you put a wet gunny bag, you wet it. So if you don't give this kind of covering, what happens in the hot arid region, right? Within 1 hour, it will become dry. See how dry they are and how wet these gunny bags are. Within 1 hour, it will become very dry. So then it will come and tell it's not being cured. So it's a very difficult to cut all this thing. So what we tried basically is to wet the gunny bag and then we just cover them with the this debonding sheet. It has several benefits, right? So we also try to test this kind of concrete cubes in our laboratory also, inside laboratory. So basically build some small labs in the site. One is water curing, other is this kind of plastic membrane curing. And then we used to see the support strength. Hardly we used to have a difference of 0.5 to 1 MPa, and both concrete used to clear a strength of 40 required strength, the concrete thing. And then there's no much difference between the strength. So this way, once you lay this wet gunny bag, cover this with a plastic membrane, right? So the water, whatever is being there in the membrane, jute bag, it will remain there only for a long time, right? It remains there only for a long time without evaporating. This will reduce a lot amount of water consumption. Other than water consumption, it will reduce the amount of fuel consumption for the water tankers, amount of water being used, and many other benefits one can achieve by this kind of curing methods, right? So and then if you want to again cure it, you just remove this stone, right, and then use a pipe, pour the water, and again close it. It has benefits like it is to avoid, it is increase the relative humidity. We talk about concrete. Concrete curing requires very high RH, relative humidity. So this plate and this cover used to give this relative humidity. And second thing, it is to reduce the effect of wind. Right? The wind effect may be high at the fresh stage of concrete or initial hardening stage. So it will completely mitigate the effect of wind. So air cannot easily pass through this particular because we should place a 12 bar or stone on this position, so air cannot pass. So this way we used to one can practice this kind of method for curing, so one can save lot of amount of good potable water. So then once you once you leave it for 28 days, right, before opening for traffic, one important step is sealant filling, right, because the glue cut what you have made, those glue cuts are full depth, right, you have made a glue cut of D by 3 and below glue cut there is a crack now, there is a now full depth crack basically, and that can allow water easily and other debris can go in the joint, right, and can affect the slab movement. To avoid, what we do is start filling the sealant. So whatever joint we have made, right, that's what called initial cutting. That initial cutting is depth is D by 3 and width is 3 to 5 mm. Now this is further widened to 10 mm approximately to a depth of around 25 mm. Right, you will use a widened blade of around 10 mm width and cut up to 25 mm. This is just you make a small spot or a small slot for filling the sealant. Before filling the liquid sealant, you place a debonding strip, or usually we also use a baker rod. You place a debonding strip. The debonding strip will prevent the sealant. So this is sealant, this debonding strip, debonding the strip. Since sealant is in liquid form, this can easily flow if you don't give this debonding strip. So to prevent the flow of this debonding sealant, into this particular slot, we put a debonding strip, then place sealant. But this sealant remains in the joint and prevent any entry of water or any other foreign materials in this particular joint, because joint is very important part of concrete pavement. And then this is how you fill the joint. You'll basically place this kind of cellophane tape or cello tape just to see that the excess sealant won't come on the concrete pavement, will affect the appearance of the concrete pavement. Later you remove this cellophane tape, only sealant remains. Okay? So if there is smudging of sealant or if it flows excess, it will flow on the sellotape, not on the concrete pavement. So appearance wise, it remains good. And again, you will place the debonding strip or baker rod and then fill the sealant. And finally, once you do all this operation, before open for traffic, you will fill the sealant, and then after 28 days of curing, you can open for the traffic, and then since that all joints are sealed. But at this point, the pavement construction is now completed. Now let's say. So now traffic is going. Sometimes what happens when traffic starts flying, and even before that also, we see some premature distresses, right? Premature distresses can occur due to various factors, we can say. Now we will see what happens if one adopts wrong practices, or if there is some issue with the mix or the practice what we adopted. So one is settlement cracks. Now concrete pavement, if you see, most concrete pavements will undergo settlement cracks during that time due to various reasons. So these kind of cracks are most common in widening projects. We go for a 2-lane to 4-lane or 4-lane to 6-lane or existing 1-lane to 2-lane road. This is very common. Settlement cracks are common. So what happens if we talk about 1-lane to 2-lane? The existing 1-lane is there or intermediate lane is there. It is 5.5 meter or 3.5 meter. And the existing 3.5 meter. So whatever base materials you have, it can be a WMM, it can be subgrade or GS, whatever layer you have, right? And if it's a flexible pavement, you'll first remove the bituminous pavement, you will clarify it, and then you will remove this. So what happens basically, the lower layers you won't disturb. Because in the contract, it will be like, okay, you'll add additional layers on to extend the need to additional layers. So the existing base layer will be properly compacted and consolidated. But the new layer what you put, the WMF, the GSD, the subgrade may not be fully compacted or fully consolidated. So over time, there will be differential settlement between the base of new layer and base of existing layer. This movement cannot be taken by the concrete. It will just settle, and the crack will occur. This is typical settlement crack. The settlement crack can be of any shape. Let's say if it is a longitudinal settlement, you can see a long crack running along the pavement. Most of the cracks are settlement is it will be along the direction of traffic. These transverse cracks, but transverse cracks will, as I told you, mostly occur because of glue cutting. So this cracks can occur because of group cutting things. And other is pop out. Pop out is basically when you have a very bad quality aggregate or the amount of clay particles are more in aggregate. So the whole the chunk will slowly start coming out, start breaking out and form small pop outs. And these small pop outs can further become a big potholes over time when the water enters in this kind of pop out. Another thing is what happens when you have a two-way road. So now here basically it's a hardened concrete and it's a wet concrete. What happens here, since it is wet and it is hardened, normally it will be a cold joint. So this cold joint is automatically a filled up joint, I mean filled up cut. So but still most of what happens, the people will start cutting here. They'll start think, okay, we need to cut the concrete and we start cutting here. We'll cut somewhere here. Right. What happens? There will be two cuts here. One cut what is being made by and this is a cut which has been formed naturally because of hardened cold concrete. So in this case, what happens? You can see here, one is cut is being made, and this is basically a cold joint. This way, in these conditions, no need to cut any groove sideways. The groove can be cut along the cold joint only. This way, you can also make a proper maintenance activities. And then double bar mark, as I told you in previous slide. See, if you don't properly the operating beam, whatever the cement or concrete it brings, it's not a proper condition, it won't properly fill this mark made by the double bar. So you can see this mark being seen in the picture, and these marks slowly will become like potholes, right? They'll attract water. What happens? It's a mark, so water will stand here, and water will be stored here for rainy season, and it slowly will weaken and become like a pot, and over time the whole joint will be destroyed, affecting the riding quality. And the other thing is this profile. See, a profile it is somewhat ups and downs. You can observe the side profile. So why it is happened? As I told you, the paver, the slip-on paver, right, is like it just moves sensor based. The sensor is placed right on the string line. And if there is an issue with the movement, if you see here, foreign waste material jumped on the DLC. So when the paver moves on this particular material, the whole level will rise and the profile will be changed basically. So the DLC surface should be clean, should be free of any foreign material. It should not dump any waste material on the DLC on the path where the paver will move. Then if something wrong happens, finally we need to remove all the slab, because in the concrete pavements we have very minimal methods of repairing concrete. Unlike flexible pavements, where you can put a layer easily. Like if something happens, you can mill it and you can put a new flexible asphalt layer. But here in concrete pavement, it's very difficult to maintain once cracks have been occurred. And if those cracks are more than depth of d/2, which is called as structural cracks, the only option is slab replacement and replacing the whole slab again. But this kind of concrete slab will be again waste, not only from point of view of contractor, it is waste from the point of material waste, right? So you might have fired so many aggregates to produce this kind of concrete. You might have wasted so much of cement, right? So much of work labor is being used. So all these losses will accumulate and may increase the loss of, may incur loss for the contract also. So this way one should be very careful while laying the concrete pavement to avoid any kind of distresses that occurs in the fresh state. If some distress don't occur in the fresh state, then it will serve for a longer duration, right, without any issues. So this should be given very careful consideration by laying concrete pavement. And then you can see one more thing, what I observed in most of roads are. So when we see concrete pavement in the flyover sections, right? We have flyover is there, or we have a VUP, vehicle underpass. We give a rise profile. In those cases, there we sometimes give a concrete pavement also, right? But what happens there? So you're placing a RE wall. RE wall is a soil below, right? There is soil. On the soil, you place DLC, then PQC slabs. If you imagine, if you compare this, it's like you're placing a butter. A thick butter is there. On the butter plate, you're placing a what to say? A plate, steel plate. When slowly butter starts melting, what happens? The plate will slowly slide. Same you can apply another here also. If soil is like a butter, if some water comes, or if some moisture entrance is there, it will start slowly moving, right? And this movement has so much effect on the concrete slab. You see here, joint widening is one of the most common thing you can observe in the rising profile of concrete pavements. If you see wherever there is a rise RE wall section, you can see there is a widened joint. Now this is basically because wherever there is a movement in the soil in the RE wall section, this or either can be transverse movement, it leads to joint widening, and the joint widening can be so much high that it can rupture tie bar. You see tie bar here, the tie bar is being ruptured. You can imagine the amount of force that has been put on tie bar. The tie bar is a steel bar which is having at least 512, I think 550 MPa strength. Now that has been pulled. Imagine the amount of stress that concrete slab movement will apply on the tie bars, right? So this way, in the sections where we have a raised profile, it's better to do flexible pavements because those flexible pavements can accommodate this kind of movements, soil movements, but rigid pavements will not accommodate this kind of soil movements, right? And this is to be one more thing on observing structure. Whereas there is a culvert, we have a culvert, right? So there, what happens? Now this is culvert section. Here we have very stiff base. It's a culvert means we have RCC, basically RCC is there, and here there is a GSD, subgrade, and GLC. What happens? There is a difference in the stiffnesses. It's very stiff. It is very less stiff. So what happens when it's moving? You can easily see a crack just where the structure is placed. So it's the width of the culvert. So at that particular thing, there is a crack. And again, these cracks are basically full width and full depth, and again very difficult to repair. Why? Because over time what happens? There will be settlement faulting. It's a faulting between this particular and this particular surface, and vehicle goes high speed, will see a very severe bump. Right? It will affect the vehicle passenger riding quality and also damage the vehicles also, and can lead to accidents also. If someone goes to very high speed and suddenly there is a high bump is there, a high faulting is there, the vehicles can go uncontrolled. And again, here the sudden dip is there. So these things should be anticipated while planning, so that at this kind of joint, you can give a dovelled joint. To give a dovelled joint there, so the faulting can be reduced, and any vehicle operating issues can be mitigated. So one should since they will be having a proper plan while planning the road, at this spot they can easily give a dovelled joint, right? So that they can avoid this kind of cracks. Because these kind of cracks within no time they become complete faulty and affect the riding quality. And second thing is again the same particular this RE wall section. You see the joint movement. Normally it is the top is 10 mm, right? What we cut. See here it is 50 mm movement. You can imagine the amount of force the concrete slab will also put on the RE wall section. Right. Now this is because the soil width is moving, right? There is some moisture entrance or some issues there. Even the rodents and the rats, whatever rodents, they can also cause a very serious damage for RE walls, because the rats and rodents start digging the soil. So this also cause very serious damage for the RE walls basically. But this is in the whenever there is the entry of moisture. So as the soil slowly moves or slowly dissipates or slowly consolidates, the thing is seen in the concrete slab also as a joint widening. It's a very serious issue because it may also apply some extra force on the RE wall, which it is not designed for, right? So then you can see settlement here, and here you can see clearly, very clearly. Now this is a DLC surface, and see the settlement amount of settlement here. There is no DLC here. Now PQC is resting on just end supports. On this end, on this end is resting. There is no DLC here. It has been settled. So you can just imagine how it will impact the future RE wall, because this is the crash barrier. Whenever it moves, it will apply force on the crash barrier, right? It can easily tilt on the other side, and sometimes it can fall also if it is worst case. So this is a settlement in the DLC. And then this was about some discussions what we found, and soon I'll finish this. Let's finish the repair methods. Now I told you the PQC has very less amount of repair methods. So one of the most followed is just remove and replace the slab. This is the worst case. And if this settlement, it's very difficult to repair. So if there is settlement between the existing and new lane, it's very difficult task to repair it basically. So normally we classify the crack depending on the depth. It can be d by 2 or less than d by 2 or more than d by 2. If it is less than d by 2, we call it as non-structural cracks. If it is more than d by 2, normally called it a structural crack. Right? So if you see full depth, and second thing, the longitudinal structural crack, right? I mean, transverse structural crack is more dangerous or more affecting than the longitudinal structural crack. That's why if you see here, the FDR, the full depth reclamation is adopted, and the longitudinal full depth is more than 12 mm. But if transverse is more than 6 mm, you go for full depth reclamation. So this is more dangerous or more damaging. Normally we have two repair methods. One is less than d by 2, that is the crack depth is thickness by 2. We go for stapling or stitching. So this is typical cross stitching. So what we do cross stitching basically, let's say a crack is there and this crack depth is less than d by 2. If it is 300 mm thick slab, let's say crack is 100 mm thickness. Then what we do, we go for a cross stitching. Basically we do this small hole, right, in the zigzag manner, right? Then this particular crack is there here. Now we do this particular hole or slot in a zigzag or staggered manner at least 150 mm from the joint or crack face. Right here, you see, from crack face at least 150 mm we give a cut here like this slot. Then we fill it. Then we fill this place steel rod here. It can be a 20 mm diameter TNT bar or a 16 mm diameter TNT bar, and then fill with the epoxy. Right, we make it to prevent entrance of water and fill the epoxy, and later these bars will be cut and made flush with the concrete surface. Now this will, what will do, it basically hold the slab, right? It reinforce the crack and also prevent any movement of the slab towards this side, because it is being reinforced now. Now this is one method called cross stitching, which is less damaging. This other method called as stapling. Now stapling is quite more damaging than the cross stitching, because you will have to make a big slot or a big groove and then place the TNT bar and then fill the epoxy. This is how the stapling is done. This is basically the groove what it has been cut to place this bent steel rod. It's like when you staple the paper, then you bring it basically here. The staple shape, you can see this particular shape of the rod, like a staple pin what we use. So it basically make this groove. Now this groove can be 1 meter long or even 5 millimeter long, depending on your requirement. Then you will make a groove at some intervals, and then you will place this particular rod inside this groove, and then fill the epoxy. Right. So this is quite damaging, because sometimes what happens, if you don't adopt proper practices, this particular small portion can act like a small beam, and a crack can occur here. Right. At this spot, you can see cracks if something goes wrong while making this particular repair method. The typical what you will see groove what is in made. This will be pushed inside the thing, and then you fill the epoxy. So why it is being done basically here, you can see there is some widening happening between the widening happening in this longitudinal joint to make them to hold the crack from future separation. This is being used. So one thing keep in mind that the longitudinal joint has tendency to open. That's why we give tie bars normally. But in the section of curves where you have super elevation, one of the best methods would be to reduce the tie bar spacing. In normal straight section, we go for a spacing of around 600 mm or 650 mm. But wherever we have curves where super elevation 5% or 7% maximum, so there the inner slab is inner and outer slab, there is too much super elevation. The inner slab has very high tendency to move from the move away. Right. So if we adopt a spacing of 650 mm, this won't work out. In those cases, you can reduce the spacing to half of the spacing. If it is 650 mm, go for 300 mm at the location where you have a curve, so that you have more tie bars and more reinforcement, and then it will hold the slab very tight without any further movement. Right. So this is typical how this slabs will move away from each other in longitudinal joint. And finally, next is full depth reclamation. FDR is basically very costly task, not only because you have to bring some materials and place it, it also involves you need to cut the slab, right? You need to bring a big saw cutter. You need to cut the slab, then you need to break the slabs. You need to dump in someone's place, right? You need to someone agrees to okay, you can dump in my place. You can else you have to pay some money to dump at a particular place, and then you have to arrange the people. Then you need to lay the concrete, right? So all this very costly task. The second thing is very unsafe also. So as in many accidents where repair things are going on in a mainly 2-lane 2-way road. When this kind of 2-lane 2-way road at night time, what happens? Someone is repairing. Even if you take full precautions, putting proper lights, placing proper sign gauges, so still some accidents will happen because due to high speed or some other reason. So it's very unsafe task also to repair a full depth slab, right? Like this way. And once you place full depth slab, you will start drilling to place tie bars, right? And also we will make drilling here also to place double bars. So whatever old double bars are there, you will remove all those old double bars, and you will have to make proper slots to place new double bars on these two faces, and here you place a tie bar by making some grooves. So finally, next we have partial depth repair. So normally carbon cracks what we see most of places where we can use partial depth repair. We can cut up to some portion. Normally cut up to 1.5 meter to 1.5 meter, and then you can remove the whole material to depth of whatever the crack is there, and you can replace. But one thing, whenever you cut a full depth here, always give a double bar. Once you give double bars here for proper load transfer from one phase to other phase. So this is my end slide. So I acknowledge Mr. Arun Kumar and Mr. B.D. Kameshwar Rao, who are my seniors in Delhi Bitcoin Limited, who helped me a lot in getting this kind of knowledge, right? So we used to share our knowledge, share our experience about roads or payments in normal office discussion. And thank you all. And this is some references what I have used in this particular making the PPT and also seeing the different guidelines. So at this point I end my slide here. So yeah, okay.
Enlightening and delightful lecture, very informative session.
Yeah.
So I hope participants have taken away the best construction practices and the best repair work practices.
Yeah, okay.
It's a wonderful session, sir.
Oh, thank you.
So at the end, I would like to propose a vote of thanks. We have come to the end of the webinar. So it's my privilege to propose a vote of thanks on behalf of SJCIT and the entire fraternity of the institution. I extend my most sincere thanks to the speaker, Dr. Anush K. Chandrapal, who has spared time from his busiest schedule to grace the event. Thank you very much, sir.
Yeah, and sorry for exceeding the time because it was a very long presentation. So my idea was to give a complete picture of complex payments. I think I exceeded the discussion time, I guess. So I don't know, audience will be.
No, sir. So no, sir. You need not ask, sir. We are very fortunate to have such wonderful session and informative sessions.
Okay. So are we taking some questions from audiences, or are we winding up?
No, sir. We have now the session is open for Q&A session.
Okay, Q&A. Okay.
So, if you have any queries, you can post queries in chat box.
So, how do you see chat box? Oh, in chat. Okay.
Yes.
Anush sir, in chat you will get the questions. So if you are seeing that, you can just respond it. And
I'm seeing some questions.
Perfect. And if you want, you can stop your sharing, and if you want to share, it's fine. Thank you.
Okay. Thank you.
Sir, you can turn on your camera, sir.
Acha, let me see. Because my if I turn on camera, the bandwidth may reduce. So not running. Actually, I'm working on Wi-Fi. I don't have LAN connection.
Oh, okay. Okay. No issues, sir. No issues, sir. You can just address the queries. Okay. No issues.
So one question from Mr. Krishnan Srinivas. So what will happen if water enters to these grooves? Then if water enters to these grooves, the water will also bring some sand, silt, right, which will fill this groove. And if this groove, if it is filled with all these foreign materials, it will affect the joint movement in future, right? It will cause very slow spalling at the joint, and this spalling may slowly generate chunks and chunks of material at the joint, affecting riding quality. Yeah, actually, audience have asked this. Thank you and all, but I think they can ask questions. I don't know how they will. Yeah. The persons have just. Yeah, I think if someone has questions because they.
Sir, I have one question.
Yeah.
In my chat box, I have one question.
Okay. Yeah, please tell me the question.
In chat box, it is from Amrita Srinivasan.
Okay.
Sir, the question is, okay, sir, is the window of groove cutting is to be finalized based on experience, or is it as mentioned 4 to 6 hours in summer and 68 hours in winter?
Yeah. So to identify groove cutting, so as I told you, one of the easy methods to identify, right? I mean, to be on safer side, you just take the groove cutting machine, which you place on the concrete surface, right? If it makes some impression, it's not the time to cut the groove. If it is able to take the particular load without making any impression, now we can start groove cutting process, right? One thing. And second thing, again, it depends on many other factors. So we cannot tell exactly this is a particular time to cut groove. So as I told you, one of the methods is we can just check the tube strength 2 to 5 MPa we get, so we can easily cut the groove. In fact, there is the other method to cut the groove also. So what happens? We call it early groove cutting, right? Right. So with placing the concrete within 1 hour, we just introduce a very small groove cut of 1 inch or even 2 inch. Right. If you take a normal blade, the normal cutting blade, right? There is a very lightweight machine, right? Because here you don't worry about groove cutting window. So within 1 hour of laying concrete, right, you will just place a 50 mm groove cut. So this 50 mm groove cut in the early stage is sufficient enough to generate the crack. In many countries, people use this method, where they will cut the groove within 1 hour of laying concrete, where they use very lightweight machines, right? Not like heavy machines, very lightweight machines, which can easily be carried on the concrete pavement in the fresh stage, and then they will make a small groove of only 50 to 1 inch. That's all.
Oh, okay. Sorry, sir. It was a question from Bharani Krishnamurthy. I guess the speaker has addressed the query clearly to M. Bharani Krishnamurthy.
Yeah.
And there is one more question, sir. It's a question from one of our panelists, Dr. Ravi Kumar K. sir. How do we avoid cracks near joints?
Near joint means.
How do we avoid cracks near joints? Yes.
No, joint means which joint? Is it a joint between a PQC and curve joint, or a joint between the concrete pavements? I mean, between the concrete.
That he has not mentioned. Probably it is the expansion joint. I guess.
Okay. Now let's say if it is joint between the curve and the concrete pavement. Now what happens? You are laying a concrete pavement, and next you lay curve also. Now since both are different times are hardening, there will be a cold joint. That joint cannot be avoided. Now that joint can be filled with the sealant. Normally what happens in the RE wall section or any other section, in normal section, if let's say median means is a curve. The curve and PQC are placed at different time, so there will be some joint between these two. That joint can be filled with the sealant to prevent entry of water. And second thing, if this avoiding joint between the cracks, right? The joint itself is a crack. The purpose of giving a joint is to generate a crack. So this way, there won't be any crack at the joint, right? So the crack is the joint basically.
Okay, sir. Next query from Mark. How can temperature produce frictional stresses in rigid pavements?
Yeah, see, the friction stress will occur because, see, what happens when there is movement, right? Now, change in temperature will try to expand on contract, right? We're trying to expand, right side, there's a restraint from the bottom. It cannot easily expand. Similarly, when it is winter, it tries to contract. Again, it will try to, it will try to restrain from the bottom. So this way, these stresses will be generated due to friction movement.
Next, we have a question from one Pandey. Sir, explain how expansion of lane is done on expressways.
Expansion of lane.
Lanes.
Yeah, see, now, normally what happens, let's say if an existing lane is there, let's say 2-lane road is there, and now you will go for a 4-lane road. So now the existing, let's say, is bituminous surface. Normally you remove the bituminous surface, then you will be, if the contract or the agreement says you retain the existing layers and you add new layers, then what they will do, they will normally give some benching. Normally will give a benching between the new layer and existing layer. It means will create like a bench. So that there is a connection between the new layer and the existing layer. So this bench will act as a medium where it won't to prevent settlement between the new and existing layer. So this benching can be seen in the cross sections of the drawing. These are typical cross sections of winding sections, whether there is a 2-lane to 4-lane winding or 4-lane to 6-lane winding. At the existing sections, right, they may show some benching. This benching is given to prevent the settlement of the new layers in future.
Okay, we have more question from M. Bharani Krishnamurthy.
Okay.
What is the method of crack filling if the cracks are finer in width but having a depth of 50 mm?
Yeah, now depth 50 mm.
Yes.
See, normally,
I repeat, what method of crack filling if the cracks are finer in width but having a depth of 50 mm?
yeah, see, now basically it is 50 mm. Normally what we do, glue cutting, what we do, it is 3 to 5 mm wider, right, initially. And later we will widen it to 10 mm and cut it to 25 mm depth. Let's say if it is more deeper, if you cut a 50 mm by mistake, let's say, so what you can do, again, you can keep a baker rod or a debonding sheet and you can fill the sealant. But normally the practice what we adopt is, we will cut the second cutting up to 25 mm depth from surface, and then you will keep a debonding sheet and then you will place a liquid sealant. But it will harden with time. If it is too deep, let's say 50 mm as the question says, again you can adopt same practice. Place a baker rod, then you can place a debonding strip and then place a liquid sealant.
Yeah. Then we have the next question from Sandeep.
Yeah.
How does the construction joint at the end of the day will be managed next day? As said in the PPT, slurry will be used. How effective is it to have nice riding surface?
No, this joint is referring to what? DLC or PQC?
That he has not mentioned. Probably the top portion.
Okay, if we refer to PQC, if we refer to the
PQC, sir.
Yeah, if we refer to the PQC, what we do basically, we will use a bulkhead. The bulkhead is basically a steel member, we can say, which is having some holes. I mean, that holes you place the double bar, right? So this bulkhead will support, will make the surface flat, right? Where the work is stopped, we'll give a bulkhead there, where the double bars will be there. So next day what we will do, next day we will start the paving to some length of the expansion, of the joint of construction. The paving will be done manually because the paver cannot start exactly at the point where you have started previous day. It will start at some distance further from the previous day's work, and the remaining the space what was left by the paver, it will be filled by the manual laying. Means you will bring the concrete and you will put some former on either side, then you will place the concrete, you will vibrate using needle vibrators, and you will finish manually. That's why if you see most of highways, depending on the rate of construction what the company has constructed, at every 300 to 400 meters, you will see small bumps. Like the same you feel in the where there is a culvert or some structure, you will feel some bump. Similar bump you will feel wherever there is a joint of expansion, because that concrete is done manually. So there will be some difference between the concrete quality achieved by slip-form paver and manual paver. So to some extent, you will pave it manually, not by slip-form paver.
Okay, sir. And from the same participant, M. Bharani Krishnamurthy. Sir,
Yeah.
what if the cement temperature is 50 degrees used for producing PQC, but mixed temperature of 30 degrees is maintained? What would be the effect on pavement at later days?
See, if you use very high temperature cement, basically it's not a good idea to use very high temperature cement, 50 degrees. So when you start producing concrete, when you dump the cement in cement silo, it will be again at 50 degrees only basically. So basically producing concrete at 50 degrees cement temperature, but when you add the water, automatically the temperature will get reduced. That is very important. So you'll add a very cold water of 3 to let's say 5 to 6 degrees. That temperature will completely reduce. That means what? Basically you're producing concrete at a very hot cement only. So again this particular is brought down to the low temperature by adding cold or chilled water. Yes.
Okay, sir. Next question is from how are the crash barriers at the RE walls made to hold on to the PQC to maintain its effectiveness?
Yeah, there are many methods where they will place the crash barrier to the distance. Normally they will give a coping beam. This is a cross section of any typical RE wall section. You can see a coping beam. So there is a friction slab on which this crash barriers will sit.
Okay, sir. Next question is from Sonu Kumar. Sir, if riverside new construction house work, how to save house joint in rainy season water? I guess it's not relevant to the topic. I guess.
Okay.
Now, next from Manjunath R. What are the precautionary measures taken if we get black bottom soil as subgrade?
Okay, so black bottom soil as subgrade is a very big issue for concrete pavement. So most of the roads in, we can say, roads in Maharashtra are a lot of black soil deposits. So if you encounter black soil, you can adopt some soil substitution methods like line stabilization. You can first to some depth, say up to 0.5 meter. You can adopt some stabilization methods in soil in order to decrease the PI and reduce the swelling index. Normally, if it is expansive, it will be having FSI of more than 50%. In that case, it's better to go with line stabilization and then reduce the PI and reduce the FSI, and then you can start laying the layers. So up to at least up to 0.5 meter or 1 meter, you can go with stabilization. If you have an option of replacing the whole black bottom soil with some other foreign good material, that can also be done depending on the material availability, right? If the black bottom is available for a small stretch of the road or project plan, so that thing can be removed, right? And then you can replace the other borrow material. If it is a full stretch black bottom soil is there, the best is to go with the line stabilization, so you can reduce the PI and expansive tendency.
Yes, sir. Next question is from Bharani Krishnamurthy.
Sachin,
robotic sand. Yes.
Sorry to interrupt you.
Yes,
sorry to interrupt you. Actually, 1:30 the session will be closed because we scheduled till 1:30.
Okay, in another. Let us take up only a few more questions.
So
in another 2-3 minutes. Okay. In another 2
so
minutes.
the feedback from people are asking for feedback form, so they're dropping the lots of messages in chat box to me. So please.
I have already shared the feedback links to all the attendees.
You did it? Because they're asking, so let me then drop the message. No problem. You can continue the questions.
Okay. Yes, sir. So we'll take only another 2-3 questions. It is from M. Bharani Krishnamurthy. Sir, is robotic sand or wash sand is a perfect replacement of natural sand? Will wash sand is also one of the reasons for developing shrinkage cracks?
See, normally when you produce PQC, so available at natural sand is very difficult. You can't use natural sand in PQC because availability is very difficult. Normally you go for a crushed sand. It's all unlike structural concrete where we prefer natural sand. In PQC we go with the crushed sand, which is basically a crushed material which is obtained from the crushing plant. So that won't be any issue with it won't be having any issue with the performance basically.
Okay, sir. I'll take the last question from Sandeep. Can the PQC be overlaid on existing PQC pavement, especially in urban sections where cracks have been developed, as I have been requested by government officials in the project?
See, overlaying PQC, it is people have tried that. There are also, I think, IRC guidelines also is there regarding this overlaying PQC layer. But when you want to overlay one PQC or other PQC, it's very difficult task. Probably you may have to, one more method is you may have to, if the existing layer is completely failed, lot of cracks are there, then you completely rumble that. You can just break it to small parts, right, and make it as like a GSB layer. On that you can place a PQC layer. This is one method that can be adopted if there are a lot of cracks and lot of failures in the existing PQC. Just you can rumble this. And there are big impact hammers are there. With this impact hammers, you can break it into small parts of approximately GSB size, and then you can pave a new PQC layer on this. Yes,
so, okay, sir. Let us wind up the Q&A session.
Okay.
So thank you for the query, sir. And I would like to bring to your that we had 47 participants across the country. Totally 650 registered participants got registered, right from Jammu Kashmir to Kerala, and right from Gujarat to Arunachal Pradesh we had participants. So it's a good thing. And also from abroad we had, from 7 countries we had participants, registered participants. From USA, United Kingdom, Ethiopia, Fiji, the Gambia, and Sierra Leone from West Africa. So even we had participants from various countries. So on behalf of SJCIT, I would like to extend my heartfelt thanks to the participants who participated from across the country and the globe. And finally, I would like to extend my thankfulness to the SJCIT family who supported in organizing this event successfully. And lastly, I will express my gratitude to our principal who have been supporting this and encouraging us continuously in organizing events.
Yeah. So also SJCIT for making this event very eventful, and it was good interaction with all of the participants also. I hope participants have taken something from this lecture. And
yes, not something that this a lot they have taken a lot and have got.
If someone has doubts, they can also mail me at akc@ibbs.ac.in. So we can mail with some questions we can discuss. So yeah, that's how we can share our knowledge. Yeah.
Yes, if the participants still have queries, you can drop a mail to the speaker. And thank you very much, sir, Anush.
Yeah.
And we expect your encouragement even in future events and your support in future events. And thank you very much, sir.
Okay. Yeah. Okay. Thank you all.
Thank you all. Stay safe. Keep social.
Yeah. Special thanks to the team of technical team. So thank you, Sachin, for conducting this particular event, and thanks to the SJCIT. So thank you, speaker Anush K. Chandrapa, And special thanks to the technical team, sir. I can understand the background work that effort you have made to make this event successful. So sincere thanks to the SAT Digital Innovation technical team. Thank you, sir.
Thank you, sir.
Yes, even I would extend my gratefulness to SAT the Digital Innovation who have provided the tech support. Thank you very much, Som.
Yeah, thanks, Sachin. Thank you. Bye-bye, everyone. Take care.
Okay.
So,
Thank you,
okay.
one and all.
Thank you all. Okay.
Stay home, stay safe. Sir, thank you, sir. Thank you, Dr. Anush, sir.
Okay, that's it. Okay. Yeah. Take care.
Bye.
See you all. See you all. Thank you.
Okay, take care, sir. See you. See you. Yes, Som, can we wind up?